to your work. I'm going to start with these so you can find it. And I'm not going to do all of them. I'm going to do one example of like each type. So first thing you should have done was find the hypotenuse, which is the longest side in the right angle triangle. And the easiest way to do that is to find the right angle, which in this case is right here. And the side that's opposite the right angle, and I use our arrow to point that, is the hypotenuse. So this side here is the longest side, also known as the hypotenuse. And we're going to call it C. And the hypotenuse is always C. The other two sides are called legs, and they're called A and B. And it doesn't matter who you call A, it doesn't matter who you call B. So, the Pythagorean theorem says that if you're a right angle triangle, then A squared plus B squared equals C squared. If I take A, which in this case is 4, and I raise it to the second power, and then B, which in this case is 8, raised to the second power, it should give me C squared. Right? So I can use this little equation here to find the missing side. So, without further ado, 4 squared is 16, 8 squared is 8 squared is 64, equals C squared, and then 16 plus 64 is 80. Right, and which equals C squared. And how do we get that C squared to look just like C? We're going to take the square root of both sides, right? And C squared becomes C because there's a little 2 over here, and that's going to just cancel out like that. And I finally have C and the square root of 80. We're going to round it to the nearest 100, so C is approximately, and it says nearest tenth, but I'm just going to keep what we did in class, which is rounded to the nearest 100, so 8.94. So this is 8.94 approx. All right, so that's an example of a problem where we needed to find the hypotenuse. Let's find one where you need to find the leg. None of these. Oh, really? Oh, here. Number 15, you need to, so again, starting off, it's a right angle triangle. So we know that the side opposite 90-degree angle is the hypotenuse, or C. And the other two sides are A and B. If you want to change that and make it B and A, that's fine. So in this case, we know the hypotenuse, the longest side, is 7.4. One of the legs, 3.6, but I don't know what this side is. So we can use the right angle, the Pythagorean theorem, which says that A squared plus B squared equals C squared. A I don't know, so I can't replace A with a value, so I'm going to keep it like this. B I do know, it's 3.6. I'll raise it to the second power. And then C is 7.4. I'm going to also raise that to the second power. So let's do some calculation. 3.6 to the second power is 12.96. So A squared plus 12.96 equals 7.4 to the second power, which is 54.76. We're going to use inverse operation. So the same steps we do to save an equation, where the variable is just A to the first power. We're going to follow those same steps. So minus 12.96 here, minus 12.96. And we're going to get that A squared equals 41.8. So now think about what that says. It says, hey, there's a number out there that if I raise it to the second power, it equals 41.8. And that's what we're trying to find. So next step, square that. Take the square root of that left side, take the square root of the right side. A squared becomes A, and then 41.8, square root of 41.8 is 6, so it's approximately 6.47, and that's the answer. So A over here, it's approximately 3.47. Okay. Let's see. I'll do one more. I'll do 16. Yeah, actually, I'll do 16 and I'll do this one because I think just to give you more. So I'll do 16. So again, go to the triangle, label the parts, right? The sides. Here's my 90-degree angle, which means the side opposite my 90-degree angle is my hypotenuse, the longest side. So we're going to call this guy C, and the other two are A and B. So we can use a Pythagorean theorem to find the missing side, which in this case is this guy here. And so set up the equation. Let's replace a with 3.9, which we're going to square it. B I can't replace because I don't know the value. And C I do, it's 11, so I'm going to take it to the second power. 3.9 to the second power is 15.21 plus b squared equals 121. Let's subtract minus 15.21 on this side, minus 15.21 on that side. So b squared equals 105.79. So we're going to square that, take the square root of that side, take the square root of the right side, and that's going to change the b squared to b. And if we take the square root, it's going to be rounded, so approximately 10.29. So b is 10.29 rounded. Okay. Let me do another one where you're missing the hypotenuse. So again, locate your 9-degree angle. It's right here. The side that's opposite the 9-degree angle is my hypotenuse, or the longest side, so that's C. The other two are going to be B and A. Okay, who you call A and who you call B, completely interchangeable. So A squared plus B squared equals C squared. A is 2, so it's 2 to the second power. B is 5, so it's 5 to the second power. And C squared. 2 squared is 4, 5 squared is 25, equals C squared. 4 and 25 is 29, which is C squared. Take the square root of both sides, and we get that C is approximately, what's the square root of 29? 5.39. So C, the hypotenuse, the longest side, it's about 5.39. Okay, so that should take care of the basic, right? And we already did this last time I saw you. So today we talked about, and again, these I'll do 9 and 11 here. So 9 and 11, the only difference between 9, the ones here in this page, and the ones we just did, they don't have pictures here, right? So you can go ahead and draw pictures. So here we have a triangle. They say that B is 12 and A is 5. So we know that A and B are always the legs, which means we're missing C, the hypotenuse, the longest side. Okay, so A squared plus B squared equals C squared. A is, sorry, I forgot to label this. So let's call that A and let's call that B. Here's my 90-degree angle. 12 squared plus 5 squared equals C squared. 144 plus 25 equals C squared. 169 equals C squared. Take the square root of both sides, and C equals 13, which is the number that we want to use. Okay. So that, again, let me do, well, this we're given the legs here. Let me do 10. 10, we're given the leg and C, which is the hypotenuse. So if you draw a triangle, and this is not to scale, right? We got A over here, which I don't know. We have B, another leg, which I do know, it's 8. And they tell me that C, the hypotenuse, is 10. Here's my 90-degree angle. The opposite side is C. Now I can use the Pythagorean theorem to find A. So A squared, A I don't know. B I do know, it's 8, so it's 64. C squared, or C, is 10. I'm going to take the second power. Sorry, I jumped the gun here. So B, let me replace it first. It's 8 to the second power. So A squared plus 64 equals 100. Minus 64, minus 64. We get that A squared is 36. Take the square root of that side, take the square root of that side, and A equals 6. So the value of A, this little leg here, is 6. Okay? So we can use a Pythagorean theorem to find the missing side. What if you're given all 3 sides? Just like this section right here. So, and the converse, what we talked about today, said that if, so the Pythagorean theorem says, if you're a right angle triangle, if you are a right angle triangle, that means that A squared plus B squared equals C squared. The converse of that says that, hey, if A squared plus B squared equals C squared, then guess what? You are a right angle triangle. Okay, so here are 3 measurements, 4, 4, and 5. If you plug it into the formula, and a squared plus b squared equals c squared, then these 3 measurements represent the sides of a right angle triangle. So let's draw it out. And again, I don't know if it's a right angle triangle yet, but I do know that 5 is the hypotenuse because it's the longest side, and the other 2 are going to be legs, right? A and B. So again, A, B, C. Notice that I didn't put this little symbol for 90 degree because I don't know if it's a 90-degree triangle yet. So let's prove it. A squared plus b squared equals c squared. A is 4 to the second power, b is 4 to the second power, and c is 5 to the second power. That's with the variables replaced by the given value. So 4 squared is 16, 4 squared is 16, and 5 squared is 25. You can obviously tell that 16 plus 16, it is not equal to 25. So these 3 do not represent the sides of a right angle triangle. Let's do, I'm going to skip, let's do 15. 15, and again, I'm going to draw it out. Here's a side that measures 6, this is 8, this is 10. And how do I know 10 is this side here? Because the longest side in a right angle triangle is a hypotenuse. This is my 90-degree angle, which I'm not going to put yet because I don't know if 6, 8, 10 are the measurements of a right angle triangle. So let's see if it works. A squared plus b squared equals c squared. So this is A, this is B, and this is C. So A and B, and this is C. A squared is 6 squared, B is 8 to the second power, and C is 10 to the second power. Well, 36 plus 64 equals 100. That's 100 equals 100. So this one worked. So I can now come back here and say, hey, these are the 3 sides of a right angle triangle. Okay. So that's what we did today. Right. I'll do a couple more in the bottom section here. The bottom section has quite a few that you can try it out. And notice that all these 3 triangles that they drew up from the following 4, 1, 2, 3, 4, none of them have this, right? Because we don't know yet if they're a right angle triangle. So let's do, I'm just going to pick a random one, 5, 12, and 13. Who is your hypotenuse? 13 has to be your hypotenuse because it's the longest side. And the other 2 are going to be A and B. Well, if A squared plus B squared equals C squared, then they are the sides that represent a right angle triangle. So A in our example here is 5, B is 12, and C is 13. 5 squared is 25, 12 squared is 144, 13 squared is 169. Let me add these. Look at that. This one worked out, right? You notice that A squared plus B squared does indeed equal to C squared. So does this represent the sides, 3 sides of a right angle triangle? Yes, and then I can come back here and do one of these, because now I know it's a right angle triangle. Okay. Eeny, meeny, miny. I'm going to do 3. So, longest side is C. The other 2 are legs. Let's see if it's a right angle triangle. 8 squared. B is 6, which is 6 squared, and C is 10 to the second power. 64 plus 36 equals 100, and this one also works out. So I can go back to triangle and do one of these. Say that's a 90-degree angle. Okay. Do a couple more here at the bottom. I'll do one more. Let's pick 6. So 6, you're given a triangle, the side measurement of a triangle. And like I said, I'm not going to put that 90-degree angle here, not yet, because I don't know. But I'm going to put this guy here. Well, actually, tell us what this C, 7.5. And C, this guy is the longest side, so that's why I made this side C. The other 2 sides, 2.1 and 7.2. Well, obviously, this is not to scale, so let's make this guy A was 2.1, and this guy here, B, 7.2. If it's a right angle, I can come back here and put that to show that's the right angle. But if, so let's prove it, that it is or it's not. So A squared plus B squared equals C squared. There's decimals, so it's 2.1 to the second power plus 7.2 to the second power, and that should be equal to 7.5 to the second power. Okay. 2.1 to the second power is 4.41. 7.2 to the second power is 51.85. Sorry, 84. And 7.5 to the second power is 56.25. Let's add these two. 51.84 plus 4.41 equals to 56.25. Oh, yay. So this does indeed, this guy, which one did I do? Here, number 6. Number 6, I can come back here and do one of these because they do represent the side measurements of a right angle triangle. Good. So everything that we did is sort of easy. The one place that you might make mistakes are in this section here. Right. Let's see. It says here, number 1, two sides of a right angle triangle are 8 and 12. Find the missing sides if these are the length of the legs. So they're telling that 8 and 12 are legs. Right, remember, this is the right angle triangle. This is C, the hypotenuse. And the other two are called A and B, and they're both called legs. This is a leg, and this is a leg. So they're telling us here that in the first one, hey, you have a triangle where the legs are 8 and 12, right? A and B. Can you find C, our hypotenuse? That's what it's telling you to do. Now you would set the equation, a squared plus b squared equals c squared. You have a and b, so a is 8 to the second power, b is 12 to the second power, and then c is what you're trying to find. 64 plus 144 equals c squared. 144 plus 64 is 208 equals c squared. Take the square root of this side, take the square root of that side, and c is 14.42 rounded. So that's that question. So I'm not concerned about that one or the second one. So the second one here, find the missing lengths of the length. So we're going to use the same measurements, but they're saying that this time around, I want you to say that 8 is a leg. So here, in the triangle, this 8 is a leg, and they're saying that the other number, 12 in this case, is the hypotenuse. Right? So this is A, and this is C, and you're asked to find B. So A squared plus B squared equal C squared. 1 second. 8 to the second power. B I don't know. C is 12 to the second power. So it's 64 plus B squared equals 144 minus 64 minus 64. B squared is 144 minus 64, which is 80. Take the square root of both sides. And square root of 80 is rounded. B is about 8.94. All right. All right, so the other ones, from now on, from 2 on, it's extremely important, at least to me, that you make a picture, that you draw it out to understand it. Give me 1 second. You can pause the video. You can. I need to do something here. Okay, just sorry. Oh shoot. Oh boy. All right, so let me see if I can make some So if I did this, and I did, sorry, only because I want to draw it out. All right, so the first question. Right, so the first question is, there's a base of a ladder placed 6 feet from the wall. So let me draw that. So imagine this is a house, right? And this is the floor. Let me change colors. And here's the ladder. It says the base of the ladder is 6 feet from the wall. So well, you see the wall here. And somebody placed a ladder right here. So they're saying that this guy over here at the bottom, from here to here, it's 6, right? And then if the ladder rests 8 feet on the wall, so where's the ladder touching? The ladder's touching right here, right? So they're saying that this guy right here is 8 feet. So how long is the ladder? So let me take that and bring it just a little bit lower without the house. So they're saying this, and here's the ladder, right? So they're saying that from the wall to the base of the ladder is 6. From the floor all the way to the top where the ladder is touching the wall, it's 8. So now they're asking, what's the length of the ladder? That's the question. So this is A, right? This is my 90 degree. This is B, and obviously this is C. So we're looking for C. So A squared plus B squared is C squared, and C represents the ladder, right? The length of the ladder. So 8 squared plus 6 squared equals C squared. What is that? 64 plus 36 equals, we've done this before, so you know that's 100. C squared, take the square root, and C equals 10. All right, so again, this part here, I don't think I should be worried about that, right? This part here worries me, right? Can you imagine what's going on? So I'm going to spend some time here. Number 2 or number 3, the bottom of a ladder must be placed 3 feet from it. So again, another wall. So let me again, let's keep it to the house, right? There's a house, and for some reason you're doing some work, right? So you're over here, and somebody brings a ladder. It says the bottom of the ladder must be 3 feet from the wall. So again, now you put a ladder there. So they're saying that this from here, from the base, right, from the bottom of the ladder and the wall is 3. So that's 3. Okay. The ladder is 12 feet long, and then they tell you that the ladder is 12 feet. And they want this case. Where is the wall touching? How high on the wall is the ladder touching the wall? So this is what that's missing. So let me bring that out just a little bit. So if you focused, right? So this is 3, this is 12, and this is what we're looking for, right? So let's label that with the appropriate letters. This is A or B, and this is B, and C is the ladder in this case. Let's find A. So A squared plus B squared equals C squared. A I don't know, so that stays. B is 3, and C is 12. So A squared plus 9 equals 144. So we're going to subtract 9 from both sides. A squared equals 135. Take the square root of both sides. A equals, hang on a second, approximately 11.62. Okay. Easy, right? Simple. So again, it's the drawing that we should be, the visual is what you should be doing to help you solve the problem. So let's look at number 4. John leaves the school to go home. Okay, so here's home, right? And here's John. He walks 6 blocks north. So north, that's 6. And then he walks. He walks 8 blocks to the west. That's, sorry. Right here. So here's John. He walks 6 blocks north, so we know that's 6. And then he walks 8 blocks west, so he's going this way. And then they're asking us how far is John from school, so this is what we're looking for, right? This distance. Well, this is your 90-degree angle. This is going to be A, this is going to be B, and in this case, we're looking for C. Okay. So let's go. So again, A squared plus B squared equals C squared. A is 8, B is 6, and then C is, we got 64 plus 36 equals C squared. This is 100 equals C squared. Take the square root of both sides, and C equals 10. Okay, so again, not that crazy. This one gave a few of you a little bit of a problem. So number 5, so I want you to understand. I'm going to draw. Here's that, and here's the river, right? I'm going to put the water. Here's the river. Okay, I'm not going to draw the whole river, but we know that here, from one side of the river to the other side of the river is 400. That's what they said here. Now, imagine you're here, right? And you're going to swim to the other side of the river. But there is a current. So, unless you're like Superman, you're probably not going to swim straight up, right? Because the current is going to push you to the right. So let me erase that. That's not really going to happen. As you swim and the current is pushing you, guess rarely, this is how you're actually swimming. So you're actually going this way. You wanted to go here, but the current pushed you a little bit to the right. So let's see what numbers are. And then it says he ends up 100 meters down the river from where he started. So this is you getting out of the water, right? So you started from here. The current, as you're swimming across the river, the current is pushing you to the right a little bit, right? And you end up here. So if you draw a triangle, right, you know that this is 100. The width is 400, so let me put 400. And they're asking you, how far did he actually swim? This is how much you swim, right? This is how much you swim. And that, in this case, is our hypotenuse. A squared plus B squared equals C squared. Let me call this 400, right? The width of the river is, let's call that A. Let's call this B. So A squared plus 100 squared equals C. Wait a second. No. B is 100. Sorry. So A is 400. 400. B, this is B. That's 100. And then C, what he actually swam, is the part that I don't know. Okay. So 400 squared is 16,000. 160,000, sorry. 1, 2, 3. 100 squared is 10,000. And then equals C squared, which I don't know, so that gives me 170,000 equals C squared, and you're going to take the square root of both sides. C, the actual distance that you swam, 1, 2, 3 equals 412.31. What is it? Feet, yards, meters. So this distance that you swam is 412.31. 7. Another ladder. The ladder problems are pretty popular. Okay, so I'm not going to draw the house. Here's the wall. The ladder, 13-foot ladder is placed 5 feet away. So it's here, right? This is the wall. So 5 foot away, somebody put a ladder, right? We put a ladder against that wall. So we know that this is 5 feet. So this is 5 feet right here, from the base of the wall to the foot of the base of the ladder. So that's 5 feet. Okay, change colors. And then the distance from the ground straight up to the top of the wall is 13. So the distance all the way to the top is 13 feet. Right? Will the ladder reach the top of the wall? Well, and the ladder is 13. So here's what the question is saying. So if you put this ladder 5 foot away at the bottom and you lean that ladder against the wall, will this ladder touch the top? Is that what will the ladder reach the top of the wall, or will it reach somewhere just below 13? Well, if you look at the triangle that we have right now, this is 5, right? This is 5, and this is 13. And let's see how high this is. We gotta find this guy. So that's A, and this is B, and this is C. So let's use the formula. A squared plus B squared equals C squared. A I don't know. B squared is 5 to the second power. C is 13 to the second power. So we get A squared plus 25 equals 169. We're going to do minus 25, minus 25. A squared equals 144. If you take the square root of both sides, A equals 12. So what that's saying is, if there's a wall that's 13 feet tall, okay, if there's a wall that's 13 feet tall, this ladder, when it's leaning over from here, right, from where the base of the ladder and the base of the building is 5 foot apart, it only reaches up to 12 feet. On the height of the wall, it only reaches. The whole wall is 13, from 0 to 13, but if you lean this ladder, it only goes up to here, to 12. So will the ladder reach the top? No, it won't. Okay, unless you bring the ladder a little bit closer to the wall, it probably will. But in this scenario, it doesn't. A diagonal of a rectangle. So let's try draw a rectangle. Think of your TV screen, and you do a diagonal. And they're saying that's 25 inches. The width is 15, so this is 15. So remember the rectangle, it's 4 right angle corners. So focus on this right angle triangle, right? And they are going to ask you for the length. So this is what we're missing. So this is C, this is B, and this is A. So A is what's missing. So A squared plus B squared equals C squared. A squared plus 15 to the second power equals 25 to the second power. A squared plus 225 is 625. We're going to subtract 225 from both sides. We get A squared is 400. Take the square root and both sides, and A equals 20. So A is the length of our rectangle is 20. Soccer field is 90 meters wide, so that's 90 meters, 120 meters going this way, right? So there's our soccer field. The coach asks players to run from one corner to the other corner, from this diagonally. So they're going to exercise, they're going to warm up by going from that corner to this corner. What is the distance that they run? Well, here's your right angle triangle, right? So we'll call the distance that I have to run C. The other two are legs. So A squared plus B squared equals C squared. So we got 120 to the second power plus 90 to the second power equals C squared. So we got 120 plus 14,400 plus 90 to the second power, which is 8,100, equals C squared. So let's add that up, plus 14,400, which gives us 22,500 equals c squared. We're going to take the square root of both sides, and c equals, let me take the square root of that, 150. So the distance that the players are going to run, which is the diagonal, is going to be 150 meters. Okay. Next one, there is a baseball diamond. Baseball diamond is a square. So for the square, we know that all the sides are the same. So this is 90, this is 90, this is 90, this is 90. What is a shorter distance to the nearest tenth of a foot between first base and third base? Well, this is first base right here, third base right here. So that's the shortest distance, right? Straight line between 2 points, the shortest distance. Here's my right angle. Here's the triangle, right? And again, we're missing the hypotenuse. C is the one that I don't know. I have A and B. And again, a squared plus b squared equals c squared. So we got 90 to the second power plus 9 to the second power. So let's see what we get. 9 to the second power is 8100. Oops. So we got 8100 plus 8100 equals c squared. So that's give us 16,200 equals c squared. Take the square root, and c, 16,200 equals 127.28 approximately, right? So c, the distance from first base, third base is approximately 127.28. Okay. Ew. Third 12, don't know, sorry, we're doing 12. So another square, but here's the problem, not problem, here's saying that we have a square and the area is 81. So if the area of a square is 81, that means the sides are 9 and 9, because 9 times 9 equals 81. So the area of the square is 81, which means the sides are 9. Find the length of the side, then find the diagonal. Well, we just did that. Each side is 9, and the diagonal, our hypotenuse, is what we're trying to find. So let's call this A, let's call this B, and just like the previous problem. So it's 9 squared plus 9 squared equals c squared. 81 plus 81 equals c squared. 162 equals c squared. Take the square root of both sides, and square root of 162 is approximately, c is approximately 12.73. Right, so that would be 13. A computer catalog. Computer monitor, this is 19 inches. The distance diagonal between the diagonal distance across the screen. Okay. If the screen measures 10 inches in height, so here's a TV screen. This is 10. What is the actual width of this? What is the actual width of the screen to the nearest inch? Okay. So here's a TV, right? And that's 10 inches. And they're saying that the diagonal here, okay, is 19 inches. Right, so let me take that, take that 10 from that side and put it on this side. Right, so the diagonal of television is 19 inches. The height's 10, and they're looking for this guy right here. So let's label a triangle. This is C. Again, here's my right angle. On the opposite side is the hypotenuse, and these two are legs, so let's call this A and B. We're looking for this, right? The length of our TV. So A squared plus B squared equals C squared. A we don't know. B is 10, so 10 to the second power, and C is 19, so 19 to the second power. 19 to the second power is 361. 10 to the second power is 100. That's A squared. Subtract 100 from both sides. We get A squared equals 261. Take the square root. And square root of 261 is approximately 16.16. Right, so that's what the length of that TV would be. 14. Donna's TV screen is 20 inches long. So Another TV problem. Right? It's 20 inches this way. The diagonal measures 25 of her TV, so let's put that's 25. What's the height? What is the width? So this is what we're looking for. So label your triangle. This is C because it's my 90-degree angle, so it's 25 is the longest side. This would be A, and this would be B. So A squared plus B squared equals C squared. A is 20, B I don't know, and C is 25 to the second power. C is 25. 400 plus B squared equals 25 to the second power, which is 625. We're going to subtract 400. So B squared equals 225. And B, well, if we take the square root of both sides, right? B equals 15. So B, the height of this TV, is 15 inches. Okay, so hopefully that helps.